We're going to use the ratio test to determine whether this series is convergent or divergent. So we're going to take the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. But we know what's going to happen, which is that we're going to have n plus 1 for all n's in this thing. So we're going to have 2, then that's an n, so we plug in n plus 1 into that. And we're going to have to distribute that too. Now we have n plus 1 factorial, and we know that we're going to multiply by the reciprocal of the original version. So without plugging in n plus 1, just taking the reciprocal is the same thing as having divided by a sub n. So this is what we have. Now we get start to simplify stuff. First of all, let's factor out that 2, because this isn't 2n plus 1. We had to plug in n plus 1 wherever we saw an n, so we distribute this 2, and this is going to give us 2n plus 2. This is 2n plus 2. Now we can notice that this is n factorial times n plus 1. N factorial times n plus 1 is what that is. So we can cancel out this n factorial with this n factorial. We can also cancel out this with all of this stuff. And what's more, we can actually cancel out this one. Because here we have 2n plus 2, but look, we're just going up by 2 each time we multiply. This is 2, this is 4, this is 6. That means that right before this one is if we subtracted 2. So that would be 2n right there. The term previous to this would have been times 2n, like that. And so we just had to notice that, and that's going to cancel out with that. It was kind of hiding in there. So now we're left with just 2n plus 2 over n plus 1. 2n plus 2 over n plus 1. We take the limit as n approaches infinity, and now the way we solve this is by dividing everything by n, both in the numerator and in the denominator. So this is going to give us 2. This is going to give us 2 over n. This is going to give us 1. And this is going to give us 1 over n. Now we plug in infinity, and this goes to 0, this goes to 0, so we're left with 2, which means that this diverges by the ratio test. Because 2 is, by the way, that's because 2 is greater than 1. And when you have something greater than 1, it diverges by the ratio test.